What's up, scholars? Today we're talking about inscribed angles. It's going to be related to circles, so I got my circle glasses on. And I realize I do a lot of this, where I look down while I write and whatnot. That was me miming writing, so I gave you a cool hat to look at in the process. Yeah, it's pretty dope. Good stuff. So let's draw a circle. I got these cool stencils that came from the city's engineering department. Got an in there. And look, check this out. This is a little stencil to help you draw radii on plan sets from civil engineers. People in the real world use circles, guys. Whoa! Anyway, back to our inscribed angles. Let's draw ourselves a nice, pretty circle, shall we? I'm gonna make mine blue. It's gonna be great. Ah, beautiful, fabulous. These little marks. We're gonna put dots here, so I can definitely make you a radius or diameter. It's gonna go right through that, and let's put another dot right here. Cool. Fabulous. Inscribed angles. What does scribe mean? To write. So we're going to write an angle in this circle. Meaning the vertex of the angle this time is actually on the circle. So I put these two dots that were directly across from each other, so this is going to be a diameter of the circle. And then the angle that's inscribed is going to be from a point on the circle itself. So right here, that is our inscribed angle. Inscribed angle. Cool. Now, we're going to relate this to the central angles we talked about before, which had their vertex at the center. So, let's say this here is our central angle, and since it is actually our diameter, we know that this angle is 180 degrees. Let me write down all the things I just said. That was our central angle. So, we have this 180 degree angle, right? It's a straight line. It subtends this arc here. Right? This angle subtends this arc, meaning the ends of the angle, right there, form that arc. Let's give those points some names. A and B and C and D. So our central angle is 180 degrees. It subtends this arc, which is also 180 degrees. And now we have this inscribed angle that also subtends the same arc, right? The ends of this angle, chop our circle up so it subtends this exact same arc. Now we know that this inscribed angle can't be the same as our 180 degree angle. That center D looks a little weird. There we go. This inscribed angle C can't be the same as our 180 degree angle, but it's related perfectly to this 180 degree angle. Okay. Turns out, when I made the circle and I made these dots, right, I made a dot right here, which was exactly halfway between these two. So that would have been 90 degrees. That would have been 90 degrees. These two arcs are the same, which means these two chords are the same. Right? It turns out this inscribed angle here is going to be exactly half of the central angle. So this inscribed angle here is going to be 90 degrees because it's exactly half of the central angle. So an inscribed angle equals exactly half of the central angle. And we know that the central angle is exactly the same as the arc it subtends. Central angle equals subtended arc with an A. So the inscribed angle is 1/2 of the subtended arc. Oh, I said subtended. Subtended arc. And I went off the page. Great. All right, let's do a couple examples. So let's say we've got a circle. We've got some inscribed angle here that is 70 degrees. Let's give these some names here, A and B and C. So we're going to find the measure of arc AC. Well, our inscribed angle is half of that arc, so 70 degrees is half of AC. Right. So 1/2 of the measure of arc AC equals 70 degrees. Slide it up. Right. The inscribed angle, 70 degrees, is half of the subtended arc. So if we wanted to find the measure of AC, we can multiply by 2 on both sides and get the measure of arc AC is 70 times 2, 140 degrees. It's as easy as that. Que fabuloso! Let's do another one. Draw another circle. Let's draw a right angle here. So now our inscribed angle is 90 degrees. Let's put some names around here. A, B, C, D. Let's find the measure of arc ABC. So again, the inscribed angle is half of the subtended arc. So our inscribed angle is 90 degrees. That's 1/2 of the subtended arc. That's the arc we're looking at. It's A to B to C. So 1/2 of the measure of ABC is going to be that 90 degrees. Multiply both sides by 2. The measure of our arc ABC is 90 times 2, 180 degrees. Too easy. Too easy. All right, let's do another one. Another circle here. Let's go the other way around. This time I'll give you the subtended arc. It's going to be 48 degrees. And let's call these points P and Q and R. And this time I want the measure of angle PQR. Well, we know the inscribed angle, which is what we're looking for, is equal to 1/2 of the subtended arc, 1/2 of this arc, which is 48 degrees, which you can't see anymore. Great. So this inscribed angle, the angle that has its vertex on the circle, is half of the subtended arc, half of 48 degrees, so the measure of angle PQR is 24 degrees. Easy peasy, lemon squeezy. All right, sweet. We've got another theorem that talks about angles that subtend the same arc. That is theorem 10.9, which says if two angles like ACB, which subtend arc AB, sorry, this circle got real oval-like, but we're pretending it's a circle. So angle ACB subtends arc AB, and angle ADB subtend the same arc AB. So if two inscribed angles subtend the same arc, those angles are congruent to each other. If two inscribed angles subtend the same or congruent arcs, the angles are congruent. So in this case, angle ACB is congruent to angle ADB because they subtend the same arc A. Both subtend arc AB. Fabulous. All right, we've got two more theorems. All right, this theorem 10.10 has an inscribed triangle. Not just an inscribed angle, it's got an inscribed triangle, meaning all of the vertices are on the circle. Let's just define that real quick. Inscribed, any inscribed polygon, all vertices are on a circle. Cool. So, theorem 10.10, we have an inscribed triangle. If the inscribed triangle is a right triangle, then the hypotenuse of that right triangle is a diameter. If an inscribed triangle is a right triangle, then the hypotenuse is the diameter. And the converse is also going to be true, meaning that if one side of an inscribed triangle is a diameter, then this inscribed triangle must be a right triangle. Converse is also true. So if one side of an inscribed triangle is a diameter of a circle, then that triangle must be a right triangle. Cool. All right, one more theorem. So this last theorem here, theorem 10.11, has another inscribed polygon because all of the vertices of this quadrilateral are on the circle. And this theorem 10.7 says a quadrilateral can be inscribed on a circle if and only if its opposite angles are supplementary. Opposite angles are supplementary. So this if and only if means this statement goes both ways. That if opposite angles in a quadrilateral are supplementary, then that quadrilateral could be drawn such that all of its vertices were on a circle. Let's just write out which opposite angles are supplementary here. This means H and F are supplementary, so the measure of angle H plus the measure of angle F would equal 180, and the measure of angle E plus the measure of angle G would equal 180 degrees. Cool. So we've got two examples here. One, we've got an inscribed triangle where we're going to find x. We have this expression 2x plus 10 equals the degrees of that angle here. We see that one side of this triangle is a diameter. So that means this must be a right triangle, which means that angle is 90 degrees. So we know 2x plus 10 must equal 90 degrees. Quick little solving, subtract 10 on both sides, we get 80 divided by 2, we get x equals 40, not 40 degrees, no, just 40, it's a number, right? Because 2 times 40 would be 80, plus 10 is 90, and this has to be a 90 degree angle because this guy here is clearly a diameter. Goes through the center and is a straight line. Awesome. All right, last one. We're going to find the measures of all of these angles. We have an inscribed quadrilateral. So that means its opposite angles must be supplementary. Excuse me. All right. Opposite angles are going to be supplementary. Let's do the easy ones first. Angle D, $100. So easy. Angle C, $75. Cushy. Opposite angles are supplementary, so D and B must add together to equal 180. So 100 plus something equals 180. So angle B, which is Y, that's going to be 80 degrees. And we can use that same theory here that these two angles must be supplementary. So we know that X plus 35 plus 75, now I'm going to write on my head, equals 180 degrees. Add our like terms, we'll get X equals 35 and 75 is 110, so that's X plus 110 equals 180. Subtract, we'll get X equals 70. Cool. That means angle A is 70 plus 35, which is 105 degrees. Great. 105 degrees. And if we added these all up, we would get how much? 360, because that's how many degrees are in a quadrilateral. Yeah. Sweet. All right, scholars, that's it. That's inscribed angles lesson. Pretty dope. Like my hat. Love you so much. I will see you next time. Peace.